So section 3.7, last section in chapter 3 here. We're going to work on polynomial and rational inequalities. So hopefully some of this is a reminder of stuff that you've done before, back in Math 1150 or whatever course you took before you came here. Now, I'm going to show you kind of the long way about some of this stuff. I'm hoping this process is going to get a lot faster, and we're not going to just work with quadratic inequalities anymore. We'll start working with cubic and quartic, etc., that is third and fourth degree. But the first thing to do is to start by getting 0 on one side. So get 0 on one side. Then you want to find and factor the roots of this polynomial. So sometimes you can do this by factorization. Sometimes you're going to need the quadratic formula. But we get two roots here, right here at -1/2 and 1/3. Those two roots divide up our real line into intervals, -∞ to -1/2, right there, and then in the middle interval, -1/2 to 1/3, and finally 1/3 to infinity. What we're going to do is we're going to test these intervals to figure out, well, where is this inequality satisfied? Where is it positive? Where is it negative? Okay, and obviously we want to know where this thing is positive, because where it's greater than 0, that's where the inequality is going to be satisfied. Now, typically speaking, what we do is you put this expression into your calculator and then you choose some test points. Test points would be things inside the intervals. So things like -2, 0, and maybe 1. Those would be good test points. Now that's all well and good, but for this kind of a problem, it might be a little bit of overkill. Why? Well, what's the shape of this polynomial? What's its graph going to look like? In general terms, not specific terms. A parabola, yeah. So it has to look something like this. In fact, it has to look a lot like this. And this graph is going to cross the x-axis at -1/2 and at 1/3. So if you're looking to figure out, well, where is this positive? Where is this graph greater than 0? That's where it's above the x-axis. That starts here and continues out that way. And there. So that's where this is above the x-axis. But keep in mind, you're going to be asked for answers that are intervals along the x-axis. So what the problem's going to want is it's going to want to know, all right, well, what's this interval? What's this interval? And those exactly correspond to the intervals that we outlined up above. It's this one and this one. That's where the function is positive, right here and here. Now, if you were to actually test that and see that, yeah, okay, I want this interval here and this interval here, great. You can do that by testing points in your graphing calculator. If you take your points, -2, 0, and 1, and plug them into your graphing calculator, you'll get y values that are going to be positive, negative, positive. And you want the positive intervals. So, great. So this is kind of like a graphical approach. Now that graphical approach is fine, but really we're going to work on more of a table approach. That is, plugging these into a table and testing points that way. So let's take a look at it that way. Take out your calculators. Let's plug in 6x squared plus x minus 1. Now for these types of problems, it's important to have your calculator set up the right way. So let me go over that right way with you. You're going to hit the second key, then the table set key. Independence should be set to ask, and dependence should be set to auto. So if you need to make some adjustments there, great. So cursor down, cursor over, press enter with the cursor over ask, like that. And then do likewise with the dependent. Table start and table delta table don't really matter for us in this case. Just independent is at ask, dependent should be set to auto. Okay, so if I go over to the table now, hit second and then the graph key, let me delete all these old values here and just start afresh. So that's going to be -2, 0, and 1. Now you can choose anything you want as long as it's in the proper interval. The important thing that I'm getting out of this is not that I got 21, -1, and 6. 21, -1, and 6. It's that it was positive, negative, positive. And that's helping me decide which intervals I want. In this case, because this is greater than 0, I want the positive intervals. So my final answer is going to be -infinity to -1/2 union 1/3 to infinity. The only part that doesn't satisfy our inequality, or the only time this dips below the x-axis, is for that little interval right in here. For that little interval, it's negative. Quick question for you. What difference would it make if I had, instead of a greater than, if I had greater than or equal to? How do you think my answer would change? That's a good question. Well, tell you what, let's zoom on this for a second. If I wanted 6x squared minus, or plus x minus 1 to be greater than or equal to 0, if that was my inequality, then let's see if I can actually use the endpoints. So if I typed in -1/2, I'd get a 0. Let's look back. If I type in a -1/2, I get a 0. Is 0 greater than or equal to 0? Yeah. So I could use the 0. How about if I typed in, say, 1/3? 1 divided by 3. Now, as soon as I hit the enter key, it's going to be replaced by a decimal, but that's okay. And I get another 0. So basically, I could use both endpoints. And so what it would do in terms of changing my answer would be -infinity to -1/2 bracket union bracket 1/3 to infinity. Yay. And I'm done. So hopefully you see the minor difference that would make. I'll kind of highlight that again with a later problem here. Now, it's not always going to be very easy to work with the graphs. It is for quadratic equations, but when we start working with other equations, say like a cubic equation, then the graphs start to get a little bit more unwieldy, like this. Now you can graph these things and try and answer them graphically. That's fine. Nothing wrong with that. In fact, let's take kind of a crack at it. I believe I gave you a link to this, so let me shut this one off. And by the way, if you got a crazy looking graph like this and you're like, I need to see it in a little different light, you can always try clicking the home button and see if that adjusts things for you. But let's go to example B here, and wow, that's kind of a really ugly looking graph. Not going to be as easy, at least with this first view, to determine where it's positive and where it's negative. Overall, we want to know where it's negative. Now, if you're pretty deft with decimals or your graphing calculator, you might be able to get a viewing window that is good enough to help you. So if I zoom in this way, then actually I guess that's zooming out. Now that's pretty good. But, you know, I've been using decimals for a few minutes now, so I'm pretty good at it. Now, you can kind of tell where this is going to be less than 0. It's going to be less than 0, that is below the x-axis, to the left of 8, between -8/3 and 6, and that's it. Just those two intervals. But that relies on you being able to interpret this graph correctly and find a good graph. So let's work at it a different way. Let's see. This one's already factored for us, so that's really nice. I know where this graph can cross the x-axis. Let's see if we can't figure those points out. this can change signs, or it can cross the x-axis at x equals 6, at x equals -8. And how am I going to find that last one, where this crosses the x-axis? Well, it's going to be where 3x plus 8 equals 0, or 3x equals -8, or x equals -8 over 3, which is the decimal value you saw on Desmos. X equals -8 over 3. Okay. Well, let's see what that brings up for us. I'm going to put these numbers on a number line. And the only thing that really matters is that I have them in the right order. I don't really have to worry about spacing them out correctly too much. So down here at -8, and then here at -8/3, and finally up here. Now, these are points on the x-axis where the function can change. Let's write down the intervals that these points create. So this first one would be -∞ to -8. How about the next one? Well, that'd be -8 to -8/3. And then -8/3 to 6, and finally 6 to infinity. If we're going to try and decide, well, where is this positive and where is this negative, and we're not going to look at the graph itself, then we're going to need to plug in this equation into our calculators so we can test some points. Yeah, please. It is being recorded, yes. So what would be some good test points? I need a point that's to the left of -8. So what's to the left of -8? Sure, -9. Something between -8 and -2 2/3. -6 will work. How about something between -8/3 and 6? What's a nice easy number? 0, thank you. And finally, something out here between 6 and infinity, 7. I mean, look, you can choose a lot of crazy numbers, but you're not getting rewarded for working extra hard. So I wouldn't bother. Let's put those things into our, let's put this expression in yellow into our graphing calculator. So I'm just going to type it in as is. You don't have to multiply it all out. That's okay. X minus 6, parentheses, x plus 8, parentheses, and then 3x plus 8. And a closing parenthesis there. So beautiful. There's our expression. All I want to do now is kind of run through this and decide, well, where does it test out positive? Where does it test out negative? And I can do that with my table function. So let's go up to the table function, hit the second key, then the graph key. Delete all the old stuff. Don't confuse yourself with the old points. Some of them might work, but let's just do the ones we already picked. -9, -6, -0, and then 7. Now I'm getting some big numbers. That's okay. All I really need to know, though, is one thing. What's that one thing that I'm going to write in blue on my sheet here? It doesn't matter that it's -285. It matters that it's negative, right? So I need to know where it's negative and positive. So it worked out like this. Negative, positive, negative, positive. A nice alternating pattern. That's typically reassuring, but it's not always guaranteed to work out like that. Which ones do I want? Do I want the negative intervals or do I want the positive intervals? I want the negative intervals. So my answer to this thing overall is simply going to be these two negative intervals. So it's going to be -∞ to -8 union negative 8/3 to 6. It's those two intervals. Now, you may be able to get that from the graph, but the graphs are going to get increasingly ugly and difficult to work with. So the easiest thing to do is just not even look at them. Just work on testing points. So, yay. All right, so we figured out where this is equal to 0. That's where the function can change signs. That's where it touches the x-axis. And then we figured out, all right, well, what's the sign of the function in those intervals? Let's just take a look back and see if this matches what we saw in decimals. Negative to the left of negative 8, and then positive between negative 8 and negative 8/3, and then negative again to 6, and then after 6 it's positive. So it does match what we saw there. And if you can do it this way, hey, you know, you don't necessarily have to test points, although I'm happy to see test points. All right. Let's try another one like that. So going back to the handout for example C here. So kind of like the last one, I'm going to list a bunch of points here. Where can this graph cross the x-axis, or touch the x-axis, I should say? What are the points I should put on my number line here? -5, -2, and 1. And that creates several intervals along the x-axis. If you're doing this at home and watching this later, maybe you want to pause the video, try and write down these intervals for yourself. So -∞ to -5, -5 to -2, -2 to 1, and 1 to infinity. Now, kind of like the last one, I'm going to put this in my graphing calculator and plug in test points. So I need some test points. What would be some suggestions for test points in each of these? -6, good. -4, good. Let's keep on going around the room. Who else? Katie? Something in this interval between -2 and 1? 0. Perfect. I was hoping you'd come up with that one. And last one. 2. Perfect. So those are great test points. We're going to take and put this expression into our graphing calculator. It's nice that it's already factored like this. That makes it easy to find the points, and I can just plug it in directly as is. So let me exit that, go over to here, parentheses, x plus 5, and then hit the square key midway down on the left-hand side, parenthesis, x plus 2, and then parenthesis, x minus 1. Just clear that out. It's getting a little messy there. Okay, then what? Well, let's test our points. So go second and then table. I'll delete our old ones just so that I don't confuse myself. And then our test points. -6, -4, 0, and 2. Yay. Pretty cool. Now, what's the important information that I needed to get from this table? It's not that I got 28 when I put in -6. What is the important part that I got from this? Good. Positive, positive, negative, positive. All right, so let's write that down. Positive, positive, negative, positive. Okay. Well, I wanted to know where this inequality was greater than 0. So which intervals are going to be my solution then? These 3 or that one? What do you think, Katie? The 1, 2, and 3? Right here? Well, the last one? Well, the last one works because this makes it positive. But the values of x in this interval also make this inequality positive. And this interval as well. So we use all 3. Because all 3 are going to make this inequality greater than 0, which is what I want. I want to know where this inequality is greater than 0. This kind of thing is used in calculus and other places all the time. But for now, let's just write down our answer. Negative infinity to negative 5 union negative 5 to negative 2 union 1 to infinity. There, let's see if it'd be nice if I got it on the screen. There is your answer. Before I say a little bit more about this, are we okay with what we got here? Thumbs up? All right. Maggie? Okay. Now, one thing to notice is that unlike the last couple, this didn't exactly alternate in sign, right? I mean, the first one I did from the handout and this one, these all alternated. But this one didn't. And the reason it didn't is because of this term right there. You had a bounce. If you were to actually look at the graph, that graph would have a bounce there instead of a wiggle through or straight through. So it actually didn't change signs at negative 5. So let me see if I can't make that a little bit more clear. Yeah, at negative 5, yeah, it touched the x-axis for a brief moment and then it bounced back up. So it was positive on both sides of this. Now, the interesting thing is that if I made this inequality greater than or equal to 0, then my answer would suddenly change from negative infinity to negative 5 to negative 2 to just negative infinity to negative 2. I wouldn't have to worry about the negative 5 because at negative 5, the value of the inequality, you'd have 0 is greater than or equal to 0. So you could include negative 5 at that point. And then these would get brackets if I made this a greater than or equal to inequality. So, all right, nice. Let's move on. Unless there's some other comments or thoughts on this one, let's move on to another question from our handout. And these are going to start with our rational inequalities. So let's see here. Yeah, so that's this right here. Maybe this shows up better than it does on my view screen, my dock camera. But a lot of the work here is very similar to what we're going to do with polynomial inequalities. With polynomial inequalities, we wanted to test points where, around where the function can change signs. And we're going to do the same thing here with rational inequalities. It's just that the way we get our points is going to be a little bit different. So, kind of like what we did with the last one, you're going to get 0 on one side. There is a little bonus step here for us. You got to write the inequality with one fraction. And that's, it's not one that I assign very often. I do assign a few like that. I'll definitely assign stuff like that in a a college algebra class like this as opposed to an intermediate algebra class. Intermediate algebra class, they get things already prettied up like we're going to see here. So let's take a look at what's going to happen right here. If you combine like terms in the numerator, now this is the cool part. This is the interactive part. You get to take part. Ooh. Someone want to tell me what I'm going to get in the numerator when I add the terms here together. Awesome, negative 5x plus 7. And so at this point, when you've got 0 on one side, what you're looking to do is find out, well, where's the numerator equals 0 and where's the denominator equals 0. Those are the points that we're going to use to create our intervals on the x-axis, just like we did for the polynomial problems just a minute ago. So roots of the numerator, well, that's going to be where negative 5x plus 7 equals 0. I'm going to move the 5x to the other side just out of my own convenience. Can anyone tell me why? Why would I move the 5x over? Why not just move the 7? By changing sides, it changes signs, so I get rid of the negative. It's just a little bit less messy. And then divide both sides by 5. So I get 7/5 as one of my possibilities. And the other one, 2x equals 1 or x equals 1/2. So those are the 2 points that I get by setting the numerator and denominator equal to 0. That creates a few intervals. So let's do the interval thing again. And again, if you want to pause the video and try and figure this out ahead of me, that's great. If not, here you go. Negative infinity to 1/2. That's one of our intervals. 1/2 to 7/5. That's another one. And 7/5 to infinity. I always encourage people to write this down because it just leads to problems when people try and do it afterwards because they confuse their endpoints of the interval with their test points. Now I need some test points as well. So test points here, here, and here. Any suggestions? How about we keep it simple? 0, 1, and 2. All right. Now we have to test that in something, and the something that you're going to test that in is right up here. That one right there. That's where we're going to test things. So let me put that expression into my calculator, and then we'll test the points 0, 1, and 2. So go to the y equals key. I'm going to clear this out. And with parentheses around the numerator, I'm going to type in negative 5x plus 7. And I need to hit a divide by key. Divided by, and then parentheses around the denominator. So 2x minus 1. So like that. Now for those of you who are interested in being a little bit more sophisticated and have your calculator up to date, you can type this in another way that won't require parentheses. If you hit the alpha key, then the y equals key, so my key history is down here. The first option allows you to write fractions more or less the way I do on my handouts and things like that. So I'll press that, and I can just type this in now without parentheses, because it's going to see, oh, well, all this is in the numerator and all this is in the denominator. So negative 5x plus 7 divided by 2x minus 1. The only drawback to this is that depending on the settings of your calculators, it might just give you a fraction as opposed to a decimal. But that's okay. All we're really interested in is whether it's positive or negative. So let's have at it with our test points. Second, and then table, delete all this stuff here, and then 0, 1, and 2. By the way, it's really nice if you show me your test points, because if I don't see them and you get it wrong, it's harder for me to give you partial credit, even if I wanted to, because I don't know where you picked up your intervals. Sometimes people choose points, inadvertently in the same interval, and that'll make a difference as to how things test out. So we had negative, positive, negative. So let's take a look at that. It was negative, positive, negative. All right, not bad. Then what? Well, did I want the positive interval or the negative interval? Do I want the positive interval or the negative intervals, I should say, plural? There's two. I want the positive. So that's this one right here. So that's going to be from 1/2 to 7/5. But if you notice, I'm not putting on the brackets or parentheses yet. Now the inequality was a greater than or equal to. So let's test both of these points. Let's test the 7/5. Let's test the 1/2 in the inequality. And this is actually kind of a cool thing you can do on the graphing calculator. So I'll start by typing in 7 divided by 5 to test one of the endpoints. And I get a 0. Can I use that one? Is 0 greater than or equal to 0? Yeah, it is. So I can use that one. And if I can use that one, that means this gets what kind of notation? Bracket or parenthesis? You're going to include it with a bracket. Excellent. Let's try the other one. Let's try 1/2. So I'll just type in 0.5. If you type in 1 divided by 2, it's going to give you the same thing. Uh-oh. Wait a minute. Are you guys getting that too? Error. Well, what's wrong? What's going on is that at 1/2, 2 times 1/2 minus 1 is 0. You're dividing by 0. That's a mathematical no-no. Don't pass go. Don't collect $200. You can't do that. So we're going to use a parenthesis here. And that's important that you get these parentheses and brackets straight. Like I said, the cool thing with the graphing calculator is that you can actually, test the endpoints and find out or remind yourself, gee, I want this one and I don't want this one. So, nice. It's a lot harder to do this graphically on Desmos or whatever, but you can see that, to the left of, say, 7/5, 7/5, somewhere in here, that the graph is above the x-axis, say to negative 1/2, or to positive 1/2. So it's tough to do it with the graph. That's why I just strongly recommend testing points. It's just cut and dry. You don't have to worry about scaling the graph so you can see it, or maybe not graphing everything, just positive or negative, and that's it. Test the endpoints. Okay, how's that one looking? Looking all right there? Let's keep going. A couple more, we're doing good. I'm going to skip up to example F here. And example F is going to be a little bit more of a pain than not. But these two come out of your homework. So I wanted to do those for you. And then the last one also comes out of your homework. So we'll do 3 more and we'll call it a day in this section. Let's see. Did I graph example F here? Let's shut this one off. Let's go down to example F. Yeah. Now, kind of an ugly looking thing because I'm going from negative 100 to 150. Start or restart by hitting the home button. Gives you a better look at this if you want to look at it that way. Still kind of a crazy graph. I wouldn't want to try and interpret it from this. And so let's go back to here. I need to find places where the numerator is equal to 0 and where the denominator is equal to 0. So can someone start me off with the numerator? Where's that equal to 0? 0. All right, so x equals 0. That's for the numerator. The denominator is more of a pain. And there's just not much I can do about it. If we want to find where this is 0, x squared plus 2x minus 1 equals 0, your options aren't really that great. I'd probably go to the tried and true one. By the way, this doesn't factor. You can try as hard as you want. It does not factor into integers. So, what's our backup plan here? Yeah, the quadratic formula. Oh boy. Shouldn't exist after an exam or after 8:30 at night, whichever comes first. But it does. So we're going to do x equals the negative of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So let me fill those things in. 2, 2, 1, negative 2, and 1. That'll simplify. You know, it should have been negative 1. No, a times c. I'm sorry. Yeah, it should have been negative 1. Yeah, 4 times a times c. So negative 1. Thank you. So that'll simplify to negative 2 plus or minus the square root of 4 plus 4 is 8. Square root of 8 over 2. And I'm going to clean this up a little bit. So it's going to be negative 2 plus or minus square root of 8 will simplify as square root of 4 times square root of 2. So in other words, I could write this as 2 square roots of 2 over 2. And if you factor out that 2 from the numerator, it'll leave behind negative 1 plus or minus the square root of 2. And let me do that here. The reason I want to do that is so that I can then cancel out that 2 in the numerator and denominator. And that'll leave me with negative 1 plus or minus the square root of 2. Not exactly the friendliest of vertical asymptotes. That's okay. It still has vertical asymptotes at these 2 points. So, wow. Let me pause for a second and let you catch up with copying that down. It might be helpful to have some approximate decimal values for these things, just to kind of know roughly where this stuff is. Not really going to need them, but I think I've got that built into our decimals link here. So I've got negative 1 minus the square root of 2. That gives me negative 2.41. And let's see, you know what? I should have had one of these as a plus. So let me make that a plus. So if you're following along at home, make that first one a plus. And the second one's a minus. Notice that that gives me the nice vertical asymptote that I want. Those things kind of thread the needle between where the function is and where it isn't. So let me zoom out a little bit on that. Make it a little bit easier to see. Whew. All right. Let's see if we can't figure out where the function is positive and where it's negative. That's what we got to do ultimately with this problem. So I'm going to go back to our handout. It's helpful to have some at least decimal value ideas of where these are so that I can line them up properly across the x-axis. So let's do that like this. By the way, I'm not likely to give many problems like this on an exam. Or if I did, maybe I'd factor it and give you the roots first or something like that. So I've got 3 points. One of them is negative 1 minus the square root of 2. And then the other one is 0 and negative 1 plus the square root of 2. I'm not trying to draw them spaced, appropriate to their size. I just have them in the right order. That's all I care about. All right. A chopper's coming in for me, so I'm going to have to leave. Yeah, and it was weird. Could you feel it? Yeah, it was weird. All right, so I need some test points in each of these. Now, like I said, it's helpful to know that this is approximately negative 2.41. So approximately negative 2.41. And this is approximately 0.41, I think. I believe that's what those were. Let's just double check back here. The reason I want to know that is because I need test points in each of these intervals. So that helps me choose a test point to the left of this. Something to the left of this would be, say, negative 3. And then something between these two, maybe negative 1. And then, yeah, you got to be kind of careful here. What am I going to choose between 0 and this? Sure. 0.2. And then over here, I can just choose 1. That'd be fine. Now, in all the work here, you're going to be plugging test points into this function. So it's that one function that has 0 on one side. That's where you've got to concentrate your efforts. So let's see if we can't do that. I'm going to plug this into my graphing calculator, and then we'll test these 4 points. I didn't take the time to write out the intervals because it's just going to be kind of a mess with all these things. So pardon me if I'm getting a little bit lazy on that one. Let's see. I'll clear this out, and this out, and this out. Start with a clean slate. X divided by parentheses x squared plus 2x minus 1. So there's my function. You have to put parentheses around the entire denominator. If you don't, there's no telling what you're going to get from the graphing calculator, but it won't be what you want. Second table, let's delete all these old values and plug in our test points. Negative 3, negative 1, 0.2, and 1. Negative, positive, negative, positive. All right. So let's mark those down on our little graph here. Negative, positive, negative, positive. Which interval or intervals do I want? Well, let's see. Our inequality was, yeah, this one right here. I'm sorry, I was looking at this one. Yeah, you're exactly right. We want the negative ones. So I would want this interval here and this interval here. Now, the thing that you have to be careful about is you can't use the endpoints here and here. They make the denominator 0, at which point it's going to be undefined. I don't know as though your graphing calculator can help you out with this one or not. Let's find out. Chances are you might get a 0, but you might get a decimal value that's deceptively close to 0. Negative 1 plus the square root of 2. Let's see. I'm honestly curious. Error. Okay, so it did kind of remind you, like, you can't use that point. Negative 1 minus the square root of 2. And error again. So it's reminding you can't use those points. So your final answer is just going to be negative infinity to negative 1 minus the square root of 2, parenthesis, because we can't use that. Can I use the 0? Let's see. If I type in a 0 here, is 0 less than or equal to 0? Yeah, it is. So I can use the 0. So union. And if I can use a 0, it means I'm going to use a bracket. And then -1 plus the square root of 2 gets a parenthesis. So that is your final answer for this one. Beautiful. Okay. 2 more. And the last one will be a little bit easier. This one is one that I chose because it's in your homework and it illustrates something that you have to take care of when you're working with these kinds of problems. And that is, we want to know where f of x is greater than g of x. So that means 1 over x is greater than 1 over x minus 1. We can't start plugging away at this thing right now. That's because you got to get 0 on one side. That's the way this method works. It's easily the best way to do these things. So that's not so bad. We'll move this to the other side, and I'll get 1 over x minus 1 over x minus 1 is greater than 0. And you're like, phew, cool, got that done. Well, not so fast. Then, let me remind you of something else we have to do with things like this, and that is, we've got to get the expression written with one fractional term. That's this part right here. You got to write it with one fraction, not two. So, oh man, now you're really putting the hurt on me because you got to get a common denominator. I know. Too much pain after an exam. I'm sorry. So the common denominator for this is x times x minus 1. So I'll just write that off to the side here. LCD is x times x minus 1. So looking at this, I need an x minus 1 term. Looking at this, I need an x term. So let me kind of take care of that. Up here, 1 over x minus 1 over x minus 1. I'm going to multiply this one by x minus 1. And I'll multiply this one by x over x. This is going to give me a common denominator. So what will I get? I'll get x minus 1 minus x over my LCD. And I'm writing LCD because I don't want anyone to cancel here. But I can clean things up in the numerator. X minus x, that cancels. I'm left with negative 1 over the LCD, which is x times x minus 1. Okay, sweet. I want to know where that's greater than 0. Negative 1 over x times x minus 1 is greater than 0. Kind of like all of these, you got to find the roots of the numerator and the roots of the denominator. Where does the numerator equal 0? Well, can negative 1 equal 0? No, it can't. So there's nothing there. There are two places where the denominator can equal 0, right? And the denominator can equal 0 at x equals 0 and at x equals 1. So these are the places that we've got to use to come up with our intervals and do our testing. Let me go back here, plug in that function, negative 1 divided by 2 sets of parentheses, x and another parenthesis, x minus 1, or you can distribute it and just put parentheses around x squared minus x. Like that. clear out all this other stuff here. Second table. Let's delete all these. Now I need some test points for these intervals. So my intervals are negative infinity to negative or to 0, 0 to 1, and 1 to infinity. What would be some easy test points? Sure. Negative 1, negative 1, 1/2, and 2. Those are some easy test points. 1/2. That's just terrible. Little Photoshop here. It's supposed to be a 1/2 in here. All right, I'm not going to mess with it anymore. So negative 1, 1/2, and 2. Negative, positive, negative. So the only interval that's going to work for us is the middle interval. So let's just take a look at that. Test it out. Negative, positive, negative. And I want to know where this is greater than 0, so I want the positive interval. For all the marbles, can I use either of the endpoints? Well, I don't have to worry about either of the endpoints because this is a greater than. But even if this was a greater than or equal to, I can't use a 0 and I can't use a 1 because those would create a 0 in the denominator. So 0, 1, that's my answer. There's one last problem here, and then we can be done with this, and it's this one. Let me look at it on my handout here. I think it'll be a little bit easier to see. A highway engineer develops a formula to estimate the number of cars that can safely travel a particular highway at a given speed. She finds that the number n of cars that can pass a given point per minute is modeled by the function 88x over 17 plus 17 times x over 20 squared. If the number of cars that can pass the given point is greater than 40, at what range of speeds can the cars travel? So you can do this on your graphing calculator, or you can do this on Desmos. I've got it set up on Desmos, so let's do that here. Let me shut these off and turn this one on. Now I'm not seeing much of the graph, so I'm going to kind of zoom out a little bit. And it starts to dip down a little bit. In fact, based on the stuff we did for the last exam, you should be able to convince yourself that eventually this graph will get down to the x-axis, that is y equals 0, because the degree of the numerator is less than the degree of the denominator. So its horizontal asymptote is 0. All right, but that's not what we're worried about. What we're worried about is where the graph is above 40. So the nice thing about Desmos is you can get these points real easy. You can find those points as well off your graphing calculator. But the number of people that can safely pass is greater than 40 when the speeds are between 9.4. Actually, I think they ask you to round this to the nearest tenth here. Round your answers to 1 decimal place. So be careful about that. If you give it 2, it'll probably mark it wrong, which is annoying to me. I'm sure it's frustrating to you as well. Sorry about that. I wouldn't do that on a test. But in any case, so the answer that you would give here would be 9.5 to 42.3. That's all there is on that one. So 9.5 to 42.3. And I'm going to use parentheses on that because this is just a greater than, not a greater than or equal to. So there's your answer on that one. Yay. All right. Comments or thoughts? Put this one in the books. Yeah, I'm good with that.